Okay, we are live. Happy to see you again for this sixth hangout. So welcome with us. We're going to be here for 45 minutes for the smart grid topic on the MOOC New Energy Technologies. So we have two colleagues here. Could you introduce yourself rapidly?
Yes, my name is Michel Benat, and I'm in charge of smart grids for RTE, the French TSO, transmission operator in France.
Thank you, Michel.
Good afternoon. I'm Laurent Javaudin. I'm a researcher in the energy team at GEM, Grenoble École de Management.
So you have met them during the MOOC. They were on the video. And we have also with us on a different place in Paris, Valériane Langsnar. Could you talk a little bit, Valériane, about yourself?
Hello, everybody. My name is Valériane Langsnar, and I am the managing director of Think Smart Grids, an association that gathers main French stakeholders in the field of smart grids.
Okay, thank you, Valériane, for this introduction. So we have just few information to share with you before the end of this session and the MOOC. You know that you have your final paper to provide before the 2nd of May. And drop it on the Dropbox on the platform. And remember that this final paper is optional. To get a certificate, you have to complete the quizzes and get more than 70% right answers. And the peer review will be open until the 9th of May to get the feedback and have completed all the MOOC. So we're going to start now with all the questions on the smart grid. And so we are waiting for all your questions. Do not hesitate. So here's the one, the first. Why was your MOOC question about smart meters? Why was your MOOC question about smart meters, which has little to do with renewable integration? So you have a point of view about this question?
Yeah, I think I can reply in a very few words. I think the module was about the smart grid.
Yes.
So that was about the connection between production and consumption, basically. And obviously, renewables are on the production side. But you don't get the full story about smart grid if you miss actually the demand side.
Yep.
And that's where smart meters come into play. The grid is about balancing supply and demand at any moment. And through the smart metering system, you can actually start to handle both sides and not just one side. So that's why we brought this question.
Indeed, I have to ask to set a compliment, because the MOOC is on new energy technologies, not just on renewable energy. And you're right, smart grids are new technologies in the energy field. They are not renewable, but they are technology that enable renewable energy. So yes, indeed, the question on smart grid and particularly smart meter was not directly linked to renewable energy, but has a key element of the smart grid. We have an information to share, and maybe we'll ask to Valériane about the results of the contest. During the last weeks, there was, the last year, a contest for smart region in France, and we get the results from massive deployment of smart grid technologies in France. Could you give us some information about these results, Valériane?
Yes, the French state has nominated the 3 regions in France that have won this contest. These are Bretagne, Britain, with their project whose name is SMILE. The other region is Provence-Alpes-Côte d'Azur, Nizza region, and the third one is the northern part of France. So these 3 regions will share between them a global price of 50 million euros, and only for Bretagne and Provence-Alpes-Côte d'Azur, there will be an amount of 80 million euros coming from the French TSO RTE and the French DSO ERDF. So these 2 regions will also share this amount in order to consolidate their grid. And let's say the global purpose of this contest is to implement smart grids at an industrial level. So we have 100 projects of smart grids in France, but now we are really going one step forward into the industrial step now. And so we are very happy that these 3 regions have been selected. And tomorrow in Bretagne, it will be the kickoff for their SMILE project. So I am very happy to share this news with you.
Thank you very much, Valériane, for this information. So we are looking for the next question. Has smart green seemed to be very promising? Should general public better be informed on the benefits? I will take the example of Linky in France. The smart meter faced some opposition from the customer. How the data will be collected in the future. So the question is about acceptance of this new technology and position of the consumer, the prosumer, facing this technology. Who wants to answer about this issue? Michel?
First, yes, I'm not in charge of the deployment of the smart meter because it's the distribution operator that is responsible for this deployment. First, I don't think it costs something for the consumer. It's supposed to be a balance between the costs and the benefits for the operator of the distribution system. There's a little, of course, there's a little resistance, I would say, against this smart meter, but it's not so much. There's about 2,000 people that say they don't need it because first maybe they have some fear about the health effects, but there's no proof that this matter has an effect on the people. And second, they don't know the benefits. The first benefit that is put forward by the distribution operator is that the people will have, let's say in live, their consumption. Every day they could see on internet what is their consumption of the day before, and they can compare it with other people that have the same house, the same people, and so on. But maybe there should be more information to the people to prove that there are real benefits from the start for them to see what is their consumptions. And the other issue is that maybe it could create new services in the future, but we don't know yet what will come. And the challenge now is to see beyond the basic function of the smart meter, that is to count, what will be the real benefits of this data. But we don't know yet what are the benefits.
Just in terms of context, the Linky is the smart meter in France that is being deployed massively in France by ERDF, the DSO, distribution system operator. It's a total of nearly 30 million smart meters. It's starting by phase 1 with selected areas. And indeed, there have been some discussion locally with some participants in certain cities that are fear the electro or magnetism of the tools. But there have been communication by ERDF regarding the threats of this emission, and it's very, very low because it's not like a GSM or a 3G or 4G. It's very, very small, and it's through CPL, online communication. So it's not through radio communication. It's mainly by cable communication. So that's an issue in France actually, and it's a quite challenge for ERDF to achieve this industrial deployment and also make it the right way with the participants. Maybe, Valériane, you want to add something about privacy?
Yes, because in fact the question was also what about the collected data will be used. So it's very important that to know and to emphasize that there will be no communication on individuals' data. So data could be used only when they are aggregated. And this could be indeed very interesting to invent, to innovate with new services. And very probably in the next week, the French ministry will launch a hackathon in order to know what kind of uses can be done with the Linky data.
Okay, thank you, Valériane. So we have a next question. Could you explain what means DSO are neutral market enablers, or TSO? Maybe explain the difference between TSO and DSO and how these operators are neutral on the market.
In France, the TSOs are, or in Europe in general, TSOs are in charge to put forward the appropriate market design. And this market design has to be neutral, related to the providers, the countries, and so on. And the first thing is that the TSO must not sell or buy anything on these markets. They have to prove that this market design don't give any advantage to any company, and let's say any big electricity company in Europe. And today, this responsibility is for the TSOs. The DSOs say that maybe in the future they could have the same kind of job at the local level. But that's why we have today a pilot project to see that if there is any benefit to put this local market in place. And we work today with the DSO to see how to cope with maybe these two levels of markets, let's say national markets and local markets, how to use the local flexibilities. Do they have to be proposed on both markets, local and national, or first locals and national, or nationals and local? What is the use case? What is the best use case for the social welfare? And this word neutral is very important, because the European Commission always says that in the countries where the DSO, or let's say the TSOs, are in the same company as a big provider, there may be doubts that these operators will give an advantage to the provider.
Okay, thanks. Yes, indeed, it's a high point about the neutrality and the independence of this grid operator, either for transportation or distribution. And it's a key point in the new market design for the future, is independency. We have another question. Could you provide some update about how smart meter data are used to create innovative tariff structure for fair relocation of cost and engaging prosumer for demand response? Laurent, what is your vision about smart meters as enabler for new services regarding demand response or dynamic tariffs?
Yeah, so maybe zooming out first, what's the whole point of demand side management in the first place? Basically, it's all about the cost of the electricity on the spot market. And at peak demand, you have actually an economic advantage if you manage to convince at least some of the consumers to momentarily stop using electricity or delay their consumption, and use electricity earlier or later when the overall demand is lower on the
it's called load shading. That's it.
Yeah. So then the question is, how do you reward the consumers who manage to shift their demand? And that's where the smart metering comes into play. You can know real time and at a very fine grain who is doing what and who is managing to shift their consumption upward or backward.
It's mainly for industrial now. In the future, it should come for residential. That's it?
Yeah, the beauty of the deployment of the Linky is that you can bring solutions which are usually for big consumers down to the households and aggregate the movements of this consumption and yield extra economic benefits when you manage to manage this demand.
Maybe Michel, you could explain what is the business of a company called Energy Pool. They were we were previously in the Energy Forum in Grenoble. This afternoon it was like a conference, and there was a company called Energy Pool. What is their business in few words? What you know about it?
Yes, of course, you know that TSOs are in charge of the demand, load, and generation balance of the country. And in France, there is a strong political will to say that a megawatt that is produced equals a megawatt that is not consumed. So we develop maybe one of the the strongest or the most relevant market design dedicated to demand response. And today, we have a market design that enables companies, aggregators, to propose demand response to the TSO. And there's one specific company that is called Energy Pool that works with industrials, and they have about 2 gigawatt of power, and they can propose, as it was the case last year, about 500 megawatt for 2 hours at peak hours, to say for 2 hours we will ask industrials to cut their process, and then it will give a way for TSO to keep the balance between the generation and the load. So today it works in France for the industrial consumers. So we pay Energy Pool for the service, and Energy Pool pays the industrial. But it's not the case for the residential and the other consumers, but maybe, and we hope that it will be the case in the future.
There's another company called Smart Grid Energy in south-west of France who is doing the same job. We have a next question. In order to match production and consumption in advanced smart grid, where is better to put the constraints? On the consumer by delaying the consumption, or on the production to adapt it, or on storage? So what is your vision about opportunities to adapt the balancing of the markets through generations, through storage, or through demand? That's a tough question.
That's a nice one.
Maybe explain what are the benefits of each one and compare it.
Or at least maybe we can look at first the production side. On the production side, for sure, I mean, where does the intermittency comes from? That's from renewables. That's something you can try to forecast. That's something you can really manage.
Yep.
For the sun, more or less. For the wind, you can predict, but you cannot manage the wind. So you have to live with that. Then, when you get to high shares of renewables in the grid, that's where you really have to manage supply and demand to maintain the balance on the grid. I like the point on storage because, as we said in the module, so far we don't have a business model that that is economically viable on a large scale for storage. You mentioned previously some startups in the region.
Yep.
In the Rhône-Alpes region, there is one called McPhee, who's using solid hydrogen to actually store electricity in solid form and restitute it to the grid. So that's called power to gas and gas to power solutions. It's interesting to see if these things will be able to come into play on a larger scale. Then on the demand side, as we said with Energy Pool, that's already working, that's already operational for big users, for industrials, and we hope in the near future we are able to go down to the level of the household.
Mm-hmm. We just listened a few minutes ago that the size of renewable reached more than 10,000 megawatts for wind capacities in France, and more than 6,000 megawatts for sun. So we are quite late regarding the German or the Spanish market, but it's growing. So we still have room to invest in renewable, but now it's growing. So that's a good point. We have a question: how profitable is the smart grid development project in Europe? So, is it a good business to invest in smart grids? Maybe the business guy, and after the TSO, who is more neutral, maybe. What is your vision about this business?
Well, let's take the obvious first. If these projects are subsidized, it's because they cannot fly by their own at the moment. We need to prove the technology, we need to prove the business models. Down the road, the whole story is about having these things to be self-sustained on an economical basis. And then, as we discussed before, storage could be viable, demand-side management can be enlarged to a new type of consumers. There are a lot of potentialities, but we are not at the full scale yet.
Okay, yeah, there's a good business anyway for equipment who are building metering, and it's a good business also for services, advice. So there's a business for all the industry to adapt to this opportunity, and also it's sometimes a good business for DSO because they can have some saving in terms of gathering the data and providing some information. We have a comment from Valériane. You want to add something, Valériane?
Yes, yes. I just wanted to say that 2 years ago, when the French government asked RTE to make a state of art of the smart grids in France, the figure of 3 billion euros for smart grids market has been told, and it is expected that we reach the double in 2020. That say a market of 6 billion euros for France, and today the market of smart grids is quoted to 30 billion euros worldwide.
Yes, I wanted to add something about what you call a neutral point of view, and about the cost-benefits analysis. And work was done by a lot of French actors last year, the operators, the ministries, providers, and so on, to compute the cost-benefit analysis on very specific smart equipment, because smart grid doesn't mean anything. You have to say what kind of equipment you want to test. And the report was made that you can find on the RTE website that give the results. Let's say for the residential demand response, what is the cost, what is the benefit, and there is a report in French and there is a report in English, so you can see what are the figures for storage, for renewables, controllability, and so on. And that will give a methodology, a single methodology for all the French projects that will come in the future.
So it's a big issue regarding the cost, the investment, and the return on investment, the benefits of deploying such technology. That's it?
That's it.
Okay.
Yeah, I think that's a very important notion here, to introduce the difference between what we call CAPEX and OPEX.
Yep.
CAPEX are the capital expenditure, so the investment you have to put up front to actually create the infrastructure. And that's what the 3 billion to 6 billion euro relate. And then you have the operation expenditures and how you have this return on investment. And here, the proof of concept still in the making.
Okay, thanks.
Yep. Another important thing is that you have to compute the value not only for the economy, but also for the environment and the employment. So you have 3 values to compute for each equipment.
Yeah, because it's reducing CO2 thanks to the integration of renewable, and it's giving also a lot of jobs to set up all the business. We have an interesting question here. On a smart grid, there are some regulation on the local level and the national level. I would add on the European level also. Is there a risk of oscillation between these 2 or 3 regulations? What is your vision about this alignment or implementation of European vision? Maybe, Laurent, you work for the European Commission also. You have a vision about these stakes between European, national, and sometimes local situation, which is not the case in France, maybe, but it could be different in Germany or in different countries. What is your position about that?
Oh, well, it's not my position, but at least I think there's one important notion to introduce here, and that's the concept of subsidiarity. So at the European level, what is set is just the overall targets, and then that trickles down. Member states of the European Union actually have to transpose the European directives in their own legal system. And then also the other things we were discussing about the creation of the market that comes from the European level, and the financing of the pilot projects also very often are the EU calls for proposals. So at the EU level, they really play on different aspects, but when it comes really to the regulation per se, it trickles down to the lower levels, and what can be solved at the local level is solved best at that level.
So what is the...
Yes, there is a risk. I will give an example on the markets. It was mentioned at the beginning that there could be local markets. And at the same time, we are in the process of market coupling at the European level. So in Brussels, in the European capital, it is believed that we have to have strong European, one single market in Europe, and we have to develop tools and so on to have market coupling at the largest area. So we do it country by country, area by area, and today we have a single price for several countries most of the time. And at the same time, it is said that there could be local markets in France, for instance. I don't say that is wrong or not, but there are two different directions, and it's not the same directions. So in the future, we'll have to say either we want one single market at the European level, or to give priority to local market with very specific and local prices.
So to summarize it, it's a European policy to implement integration and the deployment of new systems like smart grids, but most of the countries have their own way to do it, and particularities could exist on the local level, even if we're on the same frame. We have a question about innovation and business. So how do you see the role of startups and SMEs, small and medium enterprises, in the development of smart grids? So maybe you could talk about the innovation contests at RTE and your vision about innovation in the field also?
Yes, RTE decided last year to have an innovation contest on the monitoring, and the purpose was to select startups to work with, and not only startups working on the electricity or energy area, but maybe startups working on other areas such as mobility, transportation, and so on. So it was the first time we made that kind of contest, and we went all over France with a paper that say we want sensors that have such and such properties, and if you think that you have a product that can work either today or next year or in 2 years, okay, we can discuss and say if we think that we can find some kind of project to work with you. So we have, I think, about around 20 answers all over France, and we selected four startups, and we work with them next year and after, because we selected 2 startups that can give today product that we can deploy on our network. The main benefit for the startups is not money, it's to be able to put the sensors on network to see if it works or not. And for the other 2 startups, they need some further developments to be able to be put on the network to see what are the benefits of these solutions.
So it was an open innovation process, and the competitiveness cluster like Tenerdis and Derby and Cap Energy in France also participate to it. And maybe, Valériane, you have a comment about the relationship between large corporation and SMEs, and maybe about Invest in Smart Grid event?
Yes, indeed. In fact, in smart grids, our association, we are convinced that the smart grids development of the players in France can only work with this very close cooperation with SMEs and big companies, because there is this point of innovation. And very often, SMEs are leading this innovation and then are helping big companies to implement it. And this is very, very important in the smart grids field. Well, yes, and at the end of May, we will event in order to, let's say, to promote the investment in little companies. We call this event Invent Smart Grids. It will take place in Paris in order to help our SMEs to grow and to expand with their innovation products.
Thank you, Valériane, and you can find information on the website of Think Smart Grid about this event. We have a question, a technical question about how do virtual power plant operator works. Maybe could you give a definition about what is a virtual power plant and what is the impact of this concept? Yep. You want to? Could you describe what is a virtual power plant?
VPP is a kind of portfolio of generation means and consumers, and it can propose some kind of flexibility with TSO, for instance, using all this portfolio at the best time for its own benefit.
It's linked to aggregators, what we talked just before.
Yes, aggregators today work on the consumption, but we can imagine aggregators of little generation means and consumers, and can optimize this portfolio to sell flexibility to the TSO on the market.
Mm-hmm. Okay. You want to have some complementary information. And about SMEs and innovation, what do you see about innovation in smart grids as trend regarding maybe data or behavior? Do you have some insight?
Yeah, sure. I think the first thing to remember is that when we talk about innovation, that can be technology-led, but that can also be led by new usages. And from that perspective, I think the smart grid is a great playground for startups, because you can really invent new services based on data, and that means it's less expensive at the beginning for a startup to start entering the market. Typically, startups are short in cash, and when the capital cost at the beginning is lower, and that's what typically data-based startups do, then the ticket to play is lower, and that leaves a lot of room through open data for small startups to invent new services. I think smart home, for instance, the interface between the smart grid and the residential area is typically a place where you see a blossoming these days of startups offering all solutions to regulate your consumption or to improve your comfort, lower your cost in your house.
Yes, indeed, we have a lot of innovation regarding all the availability of data and to transform them into interactive tools, advices, artificial intelligence, and prescription through new behaviors. So we have a lot of companies who are emerging thanks to the growth of renewables and how to make it compatible or easy to access for smart homes, smart building, and also inside the house with quality of environment, quality of air, and all these data are connected with the smart meter sometimes. So it's integration between innovation in software that make value with energy consumption and new solutions. Okay, we have a question about, can you tell me the operating expenditure element of the smart grid? It's regarding the CapEx and the OpEx. We know that it's a huge investment in CapEx. What are the costs of maintaining smart grids operational? What are the main charges?
I think what I like about the maintenance cost is that when you think of smart grids, you don't only think about the service you provide, but you have also predictive maintenance.
Yep.
Meaning you can actually reduce through sensors, you can reduce the cost of the maintenance of your infrastructure.
Mm-hmm.
Then you have to make a distinction between enhancing the old infrastructure and actually developing and building a completely new one.
Mm-hmm.
So depending at which level of the value chain you are, the question about the cost and the maintenance, we would need to really dig into more details. For the TSO, I don't know if you have cost numbers in mind.
But as for the TSO, we hope that the smart grids and the digital solutions will decrease the capex and increase the opex, but for the global benefit at the end. So we build less infrastructure, less lines, when we will have more digital solution using all the actors on the system.
Maybe you could reduce also the OPEX. I have in mind that if you have smart systems, you can give automated information. You don't have to send people for maintenance. So I imagine that sometimes CapEx could be larger for equipment, but for digital, the CapEx will be lower. But I imagine at the end, the OPEX should be also less important.
Maybe
no?
it will less important on the asset management, but for the to operate the system and to interact with all the actors of the system, I think it will cost more. But at the end, I think the results will be positive. We hope so.
Okay, that's the future. We will.
Yeah, exactly. Just to wrap up, it's interesting that we are all using the chance to talk about that. And the last session in the smart grid module was about pilot projects.
Yep.
And that's where we're actually trying to figure out, put numbers in front of these concepts. So as we say in English, the jury is still out.
Yeah.
On the CapEx OPEX discussion.
We will have next week the final results of the Green List project, which was a huge project, and it's the final result next week. So we'll share with the participants all the information. Another question, we still have time for 2 or 3 questions now. You mentioned that the idea of Ethernet, I think, in the last lecture, is the AC-DC conversion are a threat for the deployment of Internet of Energy. So I mentioned the Internet of Energy has a new paradigm, a new framework for the future of our energy systems based on massive deployment of renewable, development of digitalization and new systems to machine, and also the integration of prosumers in the system that will generate opportunities for a new business model. So this is the concept of changing the way our energy system will be in the future, maybe less centralized, more decentralized, less one-way, but more multi-directional system. And so it's not linked to AC or DC system, so it's completely different. After, there's some opportunity of efficiency in networks with AC or DC, but for me, it's completely different from the internet concept. What are the development of continuous current, so AC and DC deployment on the grid? I know that, for example, the Savoie-Piedmont project is a continuous current system, and I think there's some experiments also between the Spanish and French. Maybe Valeria know about it. You can maybe a question.
Yes, we work a lot at the European level. We work a lot on DC lines for several reasons. First, for environment issues. Today, we don't have the choice to build the overhead line for the 400 kV, so we have to build the underground lines. There was one between France and Spain that was commissioned last year, and now we build a DC line between France and Italy, and we have several projects between France and England, France and Ireland. And the other issue is that if we want to build mesh DC networks under the sea to get the power of offshore windmills and to be used as interconnection between different countries, we have to develop R&D actions to be able to build these multi-point DC networks. So we have a lot of projects on DC to make them run, because it's not possible today to operate mesh net DC network. We have point-to-point line.
The main benefits of DC is that you have less losses. No? What is the best? What is the alternative between AC and DC?
The best solution is AC, basically. When you use DC, because we don't have the choice.
Okay.
And sometimes we have the choice for underground cable, but it's an analysis of the length of the line,
yeah,
the power going through the line. Depending on these elements, we choose either AC or DC.
But what does mean AC? Is
alternative.
Current, and DC?
Direct.
So in terms of efficiency in transportation, direct current is not more interesting. I have in mind that it was the option for, as you explained, gathering the current from windmill in offshore. So I have in mind that it's more efficient.
Usually, it may be efficient when you operate it, but at the beginning, it costs a lot more than the overhead line.
Okay.
So it's always the issue between the capex and the opex. If we had the choice, we would build only overhead lines.
Okay.
Onshore, but because of these environment issues, it's easier today to have underground DC lines, and under the sea we don't have the choice.
Yes.
It's DC lines.
Okay. Okay, we still have one more question. What is the basis of development of smart grid? Is it ant colonies, silos, open computer architecture, internet, or any other method? So that's a question about development of grids. Is there like a main framework, or is there like a repeated or a regular procedure to set up smart grids? Who want to answer this question? That's an interesting question. Valériane, you have a vision about this point?
Well, okay. If we want, we can go back to the definition of smart grids. So the definition we have is that the grids enable to smart blendly the interactions of the users on the grids. So maybe this is the basis of the development of smart grids, is considering the grid as it is today and all the innovation we can bring to it technically in order to improve these interactions, considering either the consumer, the prosumer, and also all the players who are acting on the grids. But I think that the main issue of the smart grids today is not technical. It's more related to the rules, to the regulation, and also to the legal place, and also to the business models. So let's say that maybe that today the basis of the development is more linked to our capacity to all succeed to reach an agreement on the possibility to build new business models.
Thank you for this position. So I have in mind that the development of the grid is the challenge of the next years. We have in place massive investment. We know that there are some environmental benefits. We should have economical benefits also, maybe security of supply also with this investment. And to answer a little bit about this question, my vision is that the efficiency go with the size of the implementation. If we have more massive implementation, we can reduce cost of single meters and managing an integrated way all the systems. That's a choice of France. We'll see in the future what will be the difference between very small development, like in cities, like in Germany, or in region, where in some countries the administrative level is not the size of the state, but more a regional level. We have to conclude now this session. Do you have like a wish, a share for the future, for participants, for the final paper, for the smart grid topics, or do you have like a message to share, Laurent, about the future?
Well, no, maybe about the papers.
Yes, about the paper.
I hope I can read the best ones.
Yes.
I think it's a peer
Yeah, it's a peer review.
and I'll be happy to have a look at those who get the best grades and give a feeling, get a feeling of what the participants got from the course. I'm
Sure.
very interested about that.
Yeah, indeed. So we invite all the participants to go through the final paper. As we explained, it's not mandatory, it's optional, but feel free to enjoy it, to test it. And also, we will send you a quiz about the evaluation of this MOOC. So we'll be happy to have feedbacks because it will help us to evaluate what happened, what was good and could be improved. And we'll be happy to see you in the future. So thank you, bye-bye, have fun. A few words to say bye-bye, Valériane?
Oh yes, I would like to thank all the people, all the participants who have take part to this MOOC. A special thank also to Grenoble École and NRIS who have organized it. And I really hope that the French expertise has helped our participants to understand better smart grids. Thank you.
Thank you. Bye-bye.
Thank you.
Bye-bye.
Bye-bye.